Hello, students. This lesson is on conditional statements. A conditional statement is an if-then statement. So if this condition is met, then this thing is possibly something you can conclude. So here's a conditional statement. If it is raining, if the condition of the weather is that there's rain, if that condition is present, if it is raining, then what could I conclude? Lots of things. Maybe I could conclude I need an umbrella. The weather condition is that it's raining, then I need an umbrella. When it's asking you to write the statement as a conditional, that means you want to take this information and write it in the format of if and then. And there's different ways to do this. In this one, it says the if is right here. So if you are at least 18 years old, then you can register to vote. You are at least 18 years old, then you can register to vote. Is that true? I think you might be able to register to vote before you're 18 if you will be 18 at the next election. So you guys are almost getting to that point where you'll be ready to register to vote. So think about that. All right, a triangle with all angles congruent is equilateral. This one, there's actually two right answers. So you could do if a triangle is equilateral, then all the angles are congruent. You could also write that one the other way. You could write it if a triangle has all angles congruent, then it is equilateral. Both of those are okay for this situation. And the last one, I would say if Alberto washes the car, if he's done the thing that he was asked to do, if that condition has been met, then you can the reward is that he can go to the movies. If Alberto washes the car, then he can go to the movies. A lot of our life is, we don't always use the words if then, but a lot of things that adults will say to you are in the form of a conditional statement. If you do this thing, then this is your reward. This conclusion will come. All right, so there's two parts to the conditional statement. There's the hypothesis and there's the conclusion. Sometimes we use this notation of the hypothesis being the letter P and the conclusion being the letter Q. So what's the hypothesis for these two statements? If my dog sees a squirrel, my dog sees a squirrel is the hypothesis. That is the first part. That's what comes after the word this. Now this hypothesis is different than a hypothesis in science class. This is just a part of a conditional statement that comes after the word if. So what's the hypothesis? My dog sees a squirrel. What's the conclusion? What follows from that? He's going to bark. This type of math is really good for programming, computer programming, and writing code. It's also really important if you want to study logic or be a lawyer, or just be good at winning arguments. This is good. Here is another if-then statement. It's separate, but they're kind of connected. If my dog barks, that is the new hypothesis, then the new conclusion is the squirrel will run away. Conditional statements can be true or false. So you can evaluate a conditional statement and decide whether or not it actually makes sense, whether or not that conclusion always has to follow, or if maybe it doesn't always have to follow. Maybe there's a example or a counterexample where that thing would not be always true. So I want you to focus on these two especially. If it's raining, then I need an umbrella. Is that true? Is it always true? I don't know. If it's raining, is it possible there's a situation where I don't need an umbrella? Can I think of a possibility where I wouldn't actually need an umbrella? Maybe it's raining and I'm not going anywhere, so I'm not going to need an umbrella. Or maybe it's raining, but it's that kind of rain that goes sideways and with a lot of wind. So if you take an umbrella, that would be kind of pointless because it would flip inside out. So if I can come up with just one example where that conclusion is not always going to be true, then the whole statement is false. Okay, so you look at the statement and you see if this condition has been met, if the hypothesis is true, can you think of a time when this would not be true? Okay, so if a number is even, can you think of any even numbers? Are they always divisible by 2? So 4 is even. Is it divisible by 2? Yes. 8 is even. Is it divisible by 2? Yes. 20 is even. Is it divisible by 2? Yes. Okay, if you cannot come up with something where the number is even and it's not divisible by 2, then this statement is true. All even numbers are divisible by 2. This is always true. All right, another thing we can do with conditional statements is we can flip them around. So instead of having the hypothesis first, we can switch it with the conclusion. So the original conditional has the hypothesis and the conclusion. Something called the converse reverses the hypothesis and the conclusion. It puts the conclusion first and then the hypothesis. There are other ways to move conditional statements around, but we're just going to focus on the converse. So write and determine the truth value of the converse of the conditional. So here's a conditional. If you play the trumpet, that's the hypothesis. I'm going to put a little P right there. Then you play a brass instrument. I'm going to put a little Q right there. So our job is to write the converse and then decide if it's true. Now, the original statement here is true. If you don't play a band instrument, you might not know that. But a trumpet is in the set of brass instruments. There's trombones, there's trumpets, there's tubas, there's sousaphones. A trumpet is classified as a brass instrument. So the original statement is true. It has a truth value of true. Now, if I'm going to write the converse, it's still going to have the if, and it's still going to have the then. But the middle part is going to get switched. So if you play a brass instrument, see how I put that first? Then you play the trumpet. Okay, is that true? No, you could play the French horn, you could play the sousaphone, okay? You could play the trombone, okay? And I could just give one counterexample which would show that this is true. So it's false my counter example is, let's do the sousaphone. No, let's do the tuba. Okay, counter example. Tuba is a brass instrument, but it's not a trumpet. Okay, so you want to argue with something, you want to say that's not true. If you can come up with exactly one counter example, the whole thing is false. One other thing that is important to geometry class is something called a biconditional. It's when the statement, the conditional, and its converse are both true. When the statement itself and the converse are both true, then you can smash it together and make a really extra strong statement. Okay, let me show you how to do that. So when P and Q and both have the same truth value, we can smash them together. So write a biconditional for the following conditional. What is its truth value? So if two lines intersect at right angles, that's the hypothesis, and they are perpendicular is the conclusion. If two lines intersect at right angles, then they are perpendicular. Let's just draw that really fast. We have a line and we have another line, and they intersect at right angles. And that's what perpendicular means. It means that there's a perfect right angle at all four of these corners. Okay, so that's the conditional, that's the original. And we are saying that that's true. I can't think of a situation where two lines would intersect at right angles and they wouldn't be perpendicular. And we're going to test the converse. So we're going to write if two lines are perpendicular, then they intersect at right angles. Okay, is that true? If two lines are perpendicular, it's kind of like, okay, I'm going to draw perpendicular lines. Is it true that they intersect at right angles? Yes, that is true. We have this situation where we have a conditional and its converse, both with true truth values. So we can smash them together. We can take the if and the then and create a really strong definition. This is the best way to build a definition in a geometry class. So we would say two lines I'm going to do this one, are perpendicular if and only if, and only if. And the shortcut way to write that is if with two F's. Some textbooks use that. If and only if they intersect at right angles. This last statement is a biconditional. It has the two conditions. They're equally true. So that's a biconditional. Really powerful for writing definitions. All right, that's it. Have a good day. Be good, do your homework, and I'll see you in class.